Exponent laws. What is exponent laws? An exponent is a mathematical notation that represents how many times a base is multiplied by itself. Other terms used to define exponents are power or index. An exponential term is a term that can be expressed as a base raised to an exponent. The exponents can be numbers or constants. They can also be variables. Exponents are generally positive real numbers, but they can also be negative numbers. We're going to recover 8 laws of exponents, so let's start. First, we have one exponent. One exponent should look like this. X to the power of 1 equals x. Now let's just replace those variables with real numbers. So let's say we have example 15 to the power of 1. So how you're actually going to solve this is here in the exponent it just means how many times you're going to multiply the number by itself. For example, so here we have 1, right? So we're going to multiply 15 by itself one time. And that's just not possible because it won't mean anything. So whenever you see 15 to the power of 1 and you have to solve it, it is always 15. It's always the same number. It's just like you're saying 15 times 1. It's always the same number. So 15 to the power of 1 equals 15. Anything to the power of 1 stays the same number because you're multiplying the base number by itself. Next, we have zero exponents, which is x to the power of 0 equals 1. Let's now use real numbers. So here we have 15 to the power of 0. How to actually solve this? It's kind of like the same method as the previous one, but not the same answer, nor the same exponent. So here we have 15 to the power of 0. So this law is very important, and whenever you want to come solve something like this, 15 to the power of 0, it's always number 1. It's always number 1. This is extremely important law. So 15 to the power of 0 equals 1. Whatever number you have here, but with the exponent is 0, it's always number 1. So anything to the power of 0 is always 1. This is the most important laws in exponents. Next, we have multiplication rule, which is a to the power of m times a to the power of 1 equals a to the power of m plus n. Let's use real numbers now. So 3 to the power of 2 times 3 to the power of 4. Now what you're actually going to do, you're not going to work with the base number. You're going to use the base number in the answer. So you're just going to write number 3. So as you can see here, we have 3, 3. You're just going to write number 3. But what you're actually going to work on is the exponents. So here you have 2 and 4. So if you just look at the previous example, we added those two exponents by each other, so m plus n. Here what we're going to do is the exact same. We're going to add 2 plus 4. So here 2 plus here 4, which is 6. So 3 to the power of 6. In this situation, we have to keep the base number the same and add the exponents together. Division rule. X to the power of m and x to the power of n equals, x to the power of m over x to the power of n equals x to the power of m minus n. So if we just use real numbers now, 5 to the power of 2 over 5 to the power of 4. Now how you're actually going to solve this is, what you want to do here is you just want to keep the same base number. So here we have 5, here we have 5. You're just going to write 5 on the answer, and you're going to subtract both exponents by each other. So the previous one, we added them, and now we're going to subtract them. So 5 to the power of 2 minus 4, you're going to multiply 2 by 4, which is negative 2. So 5 to the power of negative 2. Here we're going to subtract the exponents from both numbers and get the answer. Next we have negative exponent. So here x to the power of negative n equals 1 over x to the power of n. So what you're going to do here, when you have 5 to the power of negative 2, when you have a negative exponent, What you're always going to do, it's just the same exact thing as this method. So you're just always going to put number 1. You're going to make it as a fraction because you actually want to solve it and you don't want to write the negative. So what you want to do is you're going to write number 1, always number 1, no matter how much this number is, you're always going to write number 1. So number 1, and then you're going to write 5 to the power of 2. You're just going to write the exact same thing as this, but without the negative sign. Do not write the negative sign. So it's going to be like 1 over 5 to the power of 2. If we have a negative exponent, we need to write it down as a fraction. 1 over the number, then multiply it by itself, depends on the number of its exponent. So here we're not answering the question fully. If you want to answer it, you have to multiply 5 by itself 2 times by the number of its exponent. So it's like 5 times 5, which is 25, and that is the answer. But here is just the law of how you should answer it. So 1 over 5 to the power of 2. Power of a power rule. We have in brackets x to the power of m and power of n equals x to the power of m times n. So here, real numbers. Again, in brackets, 5 to the power of 2 to the power of 3. How you're actually going to solve this. So here, when you have a number and its own exponent in brackets, and you have another exponent outside the bracket, what you're going to do is you want to keep the same base number. So 5 is going to be 5, but you're going to multiply 2 by 3. You're going to multiply both exponents. So if one exponent is with its base number in a bracket and another exponent is outside, you need to multiply both exponents. So 2 times 3. So here 5 to the power of 2 times 3, which is 6. So 5 to the power of 6. When the number and its exponent is in a bracket and another exponent is outside, we have to multiply both exponents. Power of a product rule. Here we have in brackets 8 times b to the power of m equals 8 to the power of m times b to the power of m. So again, in numbers, we have in brackets 7 times 9 to the power of 3. How you're actually going to write this. This is kind of similar to the previous one, but it's another method. So here, as you can see, we have two numbers here, so 7 times 9 in brackets, and then another exponent outside the bracket. This means you have to distribute the exponent by 9 and 7 by the two numbers in the brackets. Again, you need to distribute the exponent outside the bracket into the two numbers inside the bracket. So what you're going to do is you're not going to multiply the exponent by the numbers inside the brackets. You're just going to write the exact same thing. The answer is going to be the exact same thing as this one, but you're going to write the exponents in both numbers. This may be confusing to some people, but this is what I mean. You're going to distribute 3 by both numbers, which means you're just going to write the same number here, but you're going to add the same exponent. So 7 to the power of 3 times 9 to the power of 3. You just need to write the exponent on both sides of the number. Here, when the base numbers are in a bracket and the exponent is outside, we have to distribute the exponents to the numbers. So the numbers are going to have different exponents but same numbers. So here we have two numbers here. The exponents are not the same, but they have the same number, the same sign, like it's just both positive, and it's just the same number, but they're not the same exponent. This is very confusing, but it's very easy when you start using it and learning it. Here we have power of a fraction rule. So we have x over y in brackets to the power of n equals x to the power of n over y to the power of n. Now here, let's just use real numbers. So 7 over 9 to the power of 3. Here, what you're going to do is you have to Obviously, you just want to look at the previous example, and this is very similar to the previous one, but this one is in fraction rule. So what you're going to do is you're going to distribute the exponent outside the bracket into both numbers in the fraction. So again, you're going to distribute the exponent to both numbers in the fraction. So you're just going to write the same number here, 7 and 9, but you're just going to write you're going to add the exponent above it. So 7 to the power of 3 over 9 to the power of 3. In here, we have to also distribute the exponent outside the bracket into the fraction and then write the base number with the exponent above and down. So 7 to the power of 3 over 9 to the power of 3. And that's it. Thank you.